team members Pooja, Deepika, Chaturya. Today our topic is functionally dependence. Functionally dependence means if you and we are independent variables. And X and Y are functionally dependent. So functionally dependence means Jacobian of u comma v by x comma y equal to 0. This Jacobian u comma v are functionally dependent. Otherwise, the Jacobian of u comma v by x comma y not equal to 0. Jacobian of u comma v x comma y not is equal to 0. These Jacobian are functionally independent. Functionally dependent. Chaturya will start.
Taking this question as an example for the topic. The given equations are u equals to 2x minus y plus 3z, v equals to 2x minus y minus z, w equals to 2x minus y plus z. So now we have to partial differentiate the equations. Partial differentiation of dou u by partial differentiation of dou u with respect to x. Dou u by dou x equals to 2. Now partial differentiation of u with respect to y equals to -1. Partial differentiation of u with respect to z equals to 3. And then in the same way, partial differentiation of v with respect to x, v with respect to y, v with respect to z. Then w with respect to x, w with respect to y, w with respect to z. We will continue. Yeah, then the Jacobian of u comma v comma w with respect to x comma y comma z is J of u comma v comma w whole divided by x comma y comma z is equal to that of u of x, u of y, u of z, v of x, v of y, v of z, w of x, w of y, w of z. That means the derivative of u with respect to x, with respect to y, with respect to z, and the same. Now we have to substitute the values. U of x is equals to 2, u of y is minus 1, u of z is 3, v of x is 2, minus 1, 1, and then w of x is 2, w of y is minus 1, and w of z is 1. U of x, u of y, u of z, v of x, v of y, v of z, w of x, w of y, w of z. Now we will be finding the determinant. That is 2 into, we should close this column and this row, and then minus 1, minus 1, plus 1 into 2, plus 2, plus 3 into minus 2, plus 2, and that is equal to 2 into minus 2 plus 4 plus 3 into 0. That gives us 0. So therefore, Jacobian of u comma v comma w with respect to x comma y comma z is equals to 0, which means we say that it is functionally dependent.
Okay, for this sum the determination is 0. So if it is not 0, we don't need to write the another. So it is non-functionally dependence it will happen. So it is 0. So we have to find the relation between this. Now I am finding the relationship between u, Jacobian of u, v, w by x, y, z. For this we have to take the given equations which is given in the question. So now we have to assume that u is equals to, x is equals to, in this we have to take and we have to assume that x is equals to 1, y is equals to 2 and z is equals to 3. I am taking 1 to 3, you guys can take negative values or whatever you want, you guys can take it. So first equation 1, equation 2 and equation 3. Substitute this x, y, z in all of these equations. So u equal to, from equation 1 implies u equals to 2x, x means 1 minus 2 plus 3 into z is 3. 2 minus 2 plus 3 is 9. So the answer is 9. And equation 2 implies v equal to 2 into x is 1 minus y is 2 plus minus z is 3. So 0 minus 3, which means minus 3. So equation 3 implies W equals to 2 into 1 minus 2 plus 3, which is 0 plus 3. So the values of U, V, W is U is equals to 9, V is equals to minus 3 and W is equals to 3. So this is the values which I get after applying all this in this. Now I am doing U plus V. 9 minus 3 is equals to 6. So U plus V is equals to 6, right? We can write 6 as 2 into 3. U plus V is equals to 2 into 3. So in this, what is 3? 3 means W. So U plus V is equals to 2 into W. Okay, why I do this means after you finding the relationship, you have to, in that condition, you will have to get U, V and W as well as. That's why I am taking U plus V and 6. I can write 6, but it will only get U plus V. Then where is W? So that's why I write 2 into 3. So 3 means W. That's why this is the relationship between the sum. I will give you the overview of this total concept. Okay, U, V are independent variables, X and Y are functionally dependent. If the given they give the sum and we have to do the determination of that sum. And if it is 0, then it is functionally dependent. If it is not equals to 0, then it is functionally independent. So we are taking this question as an example for this concept. And the given equations are U, V, W, and we did derivative because for this formula we have to use U is derivated by X. So we did all this and it is equals to 0. That's why we continue to write the relationship. If it is not equal to 0, then we don't need to write the relationship between them. We just say it is non-functionally independent. Thank you.